there is.
Hey, Tommy.
Yeah, sorry, we forgot to record the first part of this. Here it is. Alright, so if you're solving this, you would square root both sides, which is just going to be x equals e, but you do need to put a plus or minus there. Those are your zeros, yeah. I don't know because I haven't made it yet. There might be. No. Be anything. Alright.
So the answer is just e, x equals plus minus e?
Yeah. Okay. Mm-hmm. 0. Natural log of 1. Huh? It's a way, it's like the inverse of your exponential. So like, well, let's go ahead. I'm going to go ahead and start in the next part and I'll explain it. So, C asks you for the line tangent to the graph at x equals 1. So you got 3 things you got to have. First, our point. And to find our point, we're going to say f of 1 equals, and we're just plugging into the equation, -2 plus natural log of 1 squared, which is -2 plus natural log of 1. And so this is something that you've got to know because it's going to show up a lot with natural logs. Natural log of 1. If you forget what it is, it's 0, but if you forget what it is, say natural log of 1 has to equal something, I'm going to call it an x, right? So how do you get rid of a natural log? E to the power, e to the power. So you get 1 equals e to the x. What's the only number you could have right here for that x that's going to give you 1? It would be 0, right? So that x equals 0. So natural log of 1 equals 0. Now, you don't have to do any of that work. I was just trying to explain it to make sure everybody's with me. -2 plus 0, -2. All right, so our point is 1, -2. One thing I was going to say to you guys, too, on tangent line problems, some of you are just writing point, and you never write, like, this f of 1 equals. You really want to put the f of 1 equals. I've not been counting off for that, but you want to put the f of 1 equals.
So it's not like that. You can't just plug the point like.
Yeah, I mean, it is what you're doing, but this f of 1 lets the grader know you were plugging 1 into the original equation. And then so for our slope, we've got to find f prime of 1, but we don't have f prime yet, so we got to find f prime of x first. So we're going to label it f prime of x. Right here, it's x. We haven't plugged 1 in yet, so don't put f prime of 1 just yet. So the derivative of -2 is just 0. It goes away. Derivative of natural log of x squared is going to be 1 over x squared. But you got to use a chain rule for this one. Because x squared, you got to take the derivative of that inside stuff. So, because if you have anything besides just an x there, you got to take its derivative.
Can we just make an agreement to not let questions be on the test?
It's not easy. It's not hard. The first one's harder.
Okay.
Daniel, quit insulting other people in the class. All right. Think of it sort of like if you're taking the derivative of sine of 62x to the 4th or something, right? So if you were taking the derivative of this, the derivative of sine would be cosine. And then, say like you'd have cosine of 62x to the 4th. And then you multiply it by, gosh, 62 times 4 would be 248? No. 248, right? 248 x to the third, like this. So it's sort of the same thing here. Taking the derivative of natural log is moving this stuff to the bottom. And then you have to take the derivative of the x squared, which is what's on the inside. This is unrelated, so I'm going to erase it. All right, so it's easier if you put this over 1. Make this 2x over x squared, which is 2 over x. So that's f prime of x. We need f prime of 1, which is going to be 2 over 1, which is 2. So that is our slope. This is when we have a point and our slope. Now we just have to do our line, which is y equals 2 times x minus 1 minus 2. Yeah, I think that one's easier than the first one. Okay, questions on that part? Let me just tell you about the domain over here on 1. So, with square roots, you cannot have the square root of a negative. So, for part A, 1 minus sine x has to be greater than or equal to 0, which means 1 has to be greater than or equal to sine x if we move that sine x over to the other side. Which I like to rewrite like this. Sine x has to be less than or equal to 1. So if you think about that unit circle, sine is your y coordinate, right? Sine is going to have the highest value right here at 0. Yeah, it's a negative. You're just adding sine x. Like that. That's if you're trying to get rid of sine. You could do it, but I would just leave it like this here. So the very highest sine's ever going to be is 1. What's the very lowest it's going to be? Negative 1. That doesn't even really matter here because low numbers are okay, right? We just can't have high numbers. So sine x is always less than or equal to 1. It's just like it's a quality of sine of x. So since it's always less than or equal to 1, x, or instead of saying x is, let's say the domain is all real numbers. Domain of f of x is all real numbers. It's okay to have negative 1, because if you had 1 minus negative 1 underneath that square root, they'd both become positive, and you'd have square root of 2, which is positive. Yeah. Yeah. Because sine is always between 1 and negative 1. It's always, even if it has a negative value, because it's minus, it's going to be minus a negative and it'll be positive. So, yeah. Okay, but C is the part you really want to know about, so I wouldn't pack it up yet. C is the more difficult part. I know. You're welcome. All right, and the key's up there, but the derivative for this is negative cosine of x over 2 square root of 1 minus, actually this is B. You guys show some work here. You can't just write this down, but I'm going to let you guys do that work. That's B, but you need to show work for that. I'm just telling you the answer because we need to know that for part C. So once you do B, this is what you're going to get as your answer. So I need to know now the domain of f prime. So there are, again, 3 things that really mess us up on domain most of the time. One of them is negatives under the square root. One of them is zeros in the denominator, and the last is natural logs. Whatever you're taking natural log of has to be greater than 0. That's not a factor here, of course, because we don't have any natural logs. But now I've got the square root, and I also have a denominator. So whatever's under the square root, 1 minus sine x, has to be greater than or equal to 0. But can it equal 0 here? Okay, it cannot equal 0 because that would make the denominator of this fraction 0. So since this is in the bottom, it's slightly different than it was for part A. That is horizontal asymptotes. Pre-cal stuff, mostly. So if it was something like this, like 1 over x plus 2, we would just say x plus 2 cannot equal 0. Right? So the denominator cannot equal 0, but because this time we have a square root in the denominator, the square root has to be greater than or equal to 0, but since it's in the bottom, it can't equal 0, so we took the or equal to away.
So only for thirds you put greater than or equal to.
Correct.
And the rest is just doesn't equal 0.
Right.
And so that would be x does not equal -2.
Correct. If we were doing that particular problem, which is a side note and not related to this problem. So this time, if we move that sine x over, 1 has to be greater than sine x, or we could say sine x has to be less than 1 if you want to think of it that way. So that happens almost all of the time, except for whenever sine x equals 1, right? So we need to be thinking to ourselves, where does sine equal 1? At the top. This is 0, 1. Y coordinate is sine. So this is pi over 2. So x cannot equal pi over 2, but it can keep going. So it can keep going around. Like if I go all the way around, that would add 2 pi to it, right? Pi over 2 plus 2 pi would be 5 pi over 2. But you could go around again and again, or we could go around backwards, right? So it cannot equal pi over 2. It can't equal 5 pi over 2. It can't equal 9 pi over 2. It can't equal negative 3 pi over 2. There's an infinite number of things it cannot equal. So the way that we can cover that is we can put plus 2 pi times k here and say that k is an integer. So basically that just means it cannot equal 2 pi or 2 pi plus, it can't equal pi over 2 or pi over 2 plus any amount of 2 pi's, right? 2 pi being an entire circle. So that plus 2 pi k means that it can't be at pi over 2 or any rotations around that might happen afterwards. It's going to be less than 1 everywhere, except for whenever it does equal 1.
And so like those are the numbers to plug in for x that won't work because it's not.
Right. They do not include decimals, no, or fractions, just whole numbers plus the negatives of the whole numbers. You do have to put that k as an integer there, because if k could be 1/2 or if it could be 0.7, then it would basically include every number there is.
Like x would equal pi over 2 plus 2 pi k. It would not equal, right?
Well, it's asking for the domain, and so these are the places where it cannot equal.
Yeah. Oh, okay. So it's never equals.
Right.
So
Because
like,
if it, Right, because if it does equal pi over 2, then sign of pi over 2 is not less than 1.
Okay, so it's
So it would not, those would be the ones that cannot equal.
okay.
Okay?